We're going to calculate correlation coefficients in SPSS, and a correlation coefficient is an index of the linear relationship between two continuous variables, and they're interpreted in terms of magnitude and direction. In this case, we're going to use alpha of 0.05. I have come up with an example here, and I have chosen 5 continuous variables. And these are self-esteem, self-confidence, depression, general health, and weight. And the first 4 of these variables were measured on a 10-point scale, with 1 being the lowest and 10 being the highest, and weight is measured in pounds. Now I have 5 variables here, but a correlation coefficient is calculated only between 2 variables. So I want to calculate these for all the combinations of pairs of variables between my 5 variables. So I'm going to calculate a correlation between self-esteem and self-confidence, self-esteem and depression, self-esteem and general health, self-esteem and weight, also between self-confidence and depression, self-confidence and general health, self-confidence and weight, depression and general health, depression and weight, and finally between general health and weight. So let's go to our SPSS file here. And here are my variables: weight, depression, self-confidence, general health, and self-esteem. So I'm going to go to Analyze, and I'm going to drag down to Correlate, and then across to Bivariate, and I'll click on that. Notice that my variables are listed here in the order that they appear in my data set, and I want to put the variables in a certain order. I'm going to put self-esteem in first, so I'm going to highlight it. And then notice my arrow was pointing to the variable box. I want to move that variable over. Next, I'm going to put in self-confidence, then depression, then general health, and finally weight. Now, if you have a larger data set and you put the wrong variable in, you can just highlight it, and notice the arrow was pointing the other way. You can move it back, but I want it in the variable box. Then I'm going to click on Options, click on Means and Standard Deviations, click on Continue, and then click on OK. So notice in my output I have my variables listed in the order I input them. I have my means, my standard deviations, and my sample sizes. And here are my correlation coefficients. Now we have a phenomena with the correlation matrix that on this diagonal we have ones, and this indicates if you correlate a variable with itself, the correlation coefficient is 1. Okay, also we said that there were 10 pairs of variables, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 correlations, because the correlation coefficients above the diagonal and below the diagonal are actually mirror visions of itself. So if we go across from self-esteem and down from self-confidence, we see the correlation coefficient is 0.813, and that's the same as if we correlate self-confidence with self-esteem. So you notice these are the same above and below. So let's go back to our Word document, and I'll go past the instructions here. Now remember that I have said that we interpreted correlation coefficients in terms of magnitude and direction. The direction is simply whether the correlation coefficient is positive, in which case high scores on a variable are associated with high scores on variables, low with low, or negative. There we have high with low and low with high. And in terms of magnitude, I've given just some general guidelines here. Okay, correlation coefficients range between a -1 and a +1. The closer the correlation is to 0, the weaker the relationship. The closer it is to 1, either +1 or -1, the stronger the relationship. So roughly, if our correlation coefficient is from a -0.91 to a +0.91, we can say there's no relationship. Plus or minus 0.10 to 0.29 is a low or weak relationship. Plus or minus 0.30 to 0.59 is moderate, plus or minus 0.60 to 0.79 is strong or high, and plus or minus 0.80 to 1 is a very strong or a very high relationship. Now, you will find different textbooks that will give you slightly different numbers. This is something that's kind of a matter of personal preference, although in general they go in this direction. Okay, so what I've done is I've copied the output here into the Word document. The mean for self-esteem is 7.61. The mean for self-confidence is 7.48. So here are the rest of the means, standard deviations, and sample sizes. And again, here are the correlation coefficients. So we're simply going to take our descriptive statistics first of all, and we're going to put them in a table of mean, standard deviation, and sample sizes. So self-esteem again was 7.61, self-confidence 7.48, and filling in the rest of it is pretty straightforward. Now for the correlation coefficients, we're going to list our variables here in the first column, and we're also going to list them in the first row, and then we're going to give correlation coefficients and probability values. And along the diagonal we have ones. Now we really don't need to repeat this information because we already have it reported once above the diagonal. So just to let you see what it's like, self-esteem is correlated 0.813 with self-confidence, a minus 0.452 with depression, 0.509 with general health, and a minus 0.063 for weight, and so on. And the second number here in each little box is the probability. We can compare this to 0.05. If it's above 0.05, it is not significant. If it's below, it is significant. And then we have the sample sizes. Notice these are a little bit different, a little bit lower generally than what we have above. And that's because we need scores for each individual on two variables in order to be able to calculate the correlation coefficient. And if one of those scores is missing, that person is eliminated from the calculation. So here we have our correlation table. Self-esteem with self-confidence 0.81, with depression minus 0.45, with general health 0.51, and for weight minus 0.06. I've rounded the decimal places here to 2 places, which is generally what's reported, and the rest of them I think you could fill in. Now I'm only going to pick a few correlations to report on here. Let me pick self-esteem and self-confidence. So this again, we look at the magnitude. It's above 0.80. It's very strong. It's positive, and the probability is less than 0.05. So it's a significant correlation between self-esteem and self-confidence. The R is 0.81, probability less than 0.001. Indicates that higher self-esteem is strongly related to higher self-confidence. So notice when we have a positive correlation, a high value is correlated with another high value. Let me pick another one here. How about the relationship between depression and general health? This is a minus 0.33, and the probability is less than 0.001. Again, this is significant. So here we say the moderate, because of the number, the magnitude, negative because there's a negative sign, and significant because the probability is less than 0.05. Correlation between depression and general health indicates that higher depression is moderately related to lower general health. So again, here we have a high-low, low-high relationship. And let me do one more. Let's do the correlation between self-esteem and weight. And this is a minus 0.06, so there's really not a lot going on here. and the probability is 0.50, so this is not significant. So we can see here that the near zero, negative, and non-significant correlation between self-esteem and weight, R equals a minus 0.06, P is equal to 0.50, indicates that there's no relationship between self-esteem and depression.